All right, so on Quad 8, you're working with the quadratic formula. And there are two basic Algebra 1 skills that you need to be familiar with so that you can simplify your answers. So let's say you do the quadratic formula and you end up having an answer that looks like this. 12, I don't like that pen. 12 plus or minus the square root of 60 all over 18. For instance, let's just say that that's your answer. Well, the first thing we want to think about is we have to simplify that radical. So let's first talk about how do we simplify radicals. So there's two different ways you can simplify radicals, and I suggest if you're a little uncomfortable with simplifying radicals, practice both and see which one you like better. One way is to take the square root of 60 and to think of all your perfect squares, like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and so on and so forth. And think about the highest perfect square that 60 is divisible by. And sometimes you might have to grab your calculator to try this. So for instance, if you think, oh, maybe I can simplify it by 36, you'll just go 60 divided by 36, and you'll say, oh, wait, that's not a whole number. So you're going to keep trying. And in this case, you'll find out that 60 is divisible by 4. So instead of writing this as the square root of 60, you're going to write it as the square root of 4, which is your perfect square, and the square root of 15. 4 times 15 is still 60, so you haven't changed the number. You've just broken it apart into two multiples. I always put the one that is the perfect square first. It just makes your life a little bit easier. So now you're going to take the square root of 4. Well, the square root of 4 is simply 2. And then this radical 15 is, that's as simplified as it gets. You know it's as simplified as it gets because if I broke it down, I could say 3 and 5. Well, 3 and 5 are both prime, and neither one repeats, so I know I can't simplify 15 anymore. Neither one is a perfect square. So in this case, we know that this square root of 60 would be 2 times the square root of 15. But there's one other thing you need to consider. So let's just substitute that back into our original expression. And when you have a radical that looks like this, you need to look at all three of these numbers, 12, 18, and 2. If you can simplify those three numbers, and you have to be able to simplify all of them by the same thing, then you should. So I can divide 12 by 2, 18 by 2, and 2 by 2, so I'm going to do that. So 12 divided by 2 is 6. 2 divided by 2 is just 1, so I can just leave that off. And 18 divided by 2 is 9. So if I got 12 plus or minus the square root of 60 over 18, it would actually simplify down to 6 plus or minus the square of 15 over 9. Now, if you wanted to, you could write this as 6 over 9 plus or minus the square root of 15 over 9. You could break this up into two separate fractions, and then you could go ahead and simplify this 6 over 9, divide both by 3, and you would get 2 over 3. And that would be fine as well, but you don't have to. You could stop here. The other thing that you have to think about is if you get an answer that might look like this, perhaps, plus or minus the square root of 5. Whoops, that's not what I meant to do. Plus or minus 5 over the square root of 2. Now, this is a perfectly legitimate answer, except that there is a rule, a light rule, but a rule that we will follow, that you cannot have a radical in the denominator. And the way that you get rid of that radical in the denominator is you multiply it by what the radical is. So I'm going to multiply the top and the bottom by square root of 2 over the square root of 2, because that's like multiplying this fraction by 1, so I'm not really changing the fraction. So I'll get plus or minus 5 square root of 2. Square root of 2 times the square root of 2 is the square root of 4, but the square root of 4 is 2. So plus or minus 5 over the square root of 2 is the same thing as saying plus or minus 5 square root of 2 over 2. It's just that this is simplified in the fashion that we want to by what is called rationalizing the denominator. So if you have any questions on that, let me know.